Now let's turn our attention to how weather systems move from place to place. Watch weather reports for a few days, and you will probably see weather systems move from one location to another. Weather conditions change from day to day because of the movement of air masses. An air mass is a large body of air that takes on characteristics and conditions similar to the area that the air mass forms over. Air masses can form over land or over water, and either in polar regions or in the tropics. Here is a map that shows the common air masses that affect the weather for the continental United States. Air masses take on the characteristics of the area in which they form. The continental polar air mass would be cold, dry air. The air mass over water in the tropics is moist, warm air. Air masses forming over water are moist, and air masses forming over land are dry. Air masses move from one location to another because of wind. Wind is air in motion. It is put into motion by the energy of the sun. Some parts of the earth are heated more than others by the sun. The air above these hot spots is warmed and rises because it is less dense than surrounding air. Here is a simple demonstration that shows why warm air is less dense than cold air. A small amount of air is blown into the balloon, and then the balloon is stretched over the mouth of the bottle. As the air in the balloon and bottle is heated, the balloon expands. Air molecules move faster and more vigorously when heated. Because of this increased energy and motion, the molecules bounce around and move farther away from each other. The balloon expands as a result of this activity. Warm air is less dense than cold air because the molecules of warm air spread out and require more room than molecules of cold air. Air molecules are held close to the earth by gravity. If we weigh a column of air 1 inch square from sea level to the top of the atmosphere, it weighs almost 14.7 pounds. If more air molecules are packed into the column, the weight goes up and the pressure increases. So, cold, dense air has greater pressure than warm air, which is less dense. Winds always move from areas of high pressure into areas of low pressure. So, cold, dense air moves to the low pressure areas of warm air. On a weather map, there are areas identified with an H for high pressure and areas marked with an L for low pressure. The thin lines on the map are called isobars. They connect weather stations with the same pressure readings. The numbers are in special units called millibars of pressure. On a warm summer day at the beach, you may have felt a cooling breeze. This happens because the land heats up faster than the water. As the air above the heated land rises, then the cool air over the water moves in to replace it. At night, the opposite happens. The water holds on to the heat longer than the land, so the air above the water is heated and rises as cool air above the land sinks and moves out from the land to the water. These sea breeze winds only affect a small region. The air above the equator is heated and forced upwards by the colder, denser air that moves in underneath it. The warmer air moves toward the North Pole, while cooler air from the North Pole moves south. If the Earth didn't rotate, this movement of warm air north and cold air south would be the circulation pattern for our planet in the northern hemisphere. In the southern hemisphere, the warm air of the equator would rise and move south toward the South Pole, while the cold air of the South Pole would move north. However, the Earth does rotate, and as a result, winds are bent to the right north of the equator and to the left south of the equator. This is called the Coriolis effect, and it can be illustrated by thinking of a rocket launched from the North Pole toward New York City. Because the Earth spins, the rocket would land in Chicago. We'll use this turntable to illustrate the Coriolis effect. If the marble is released, it rolls across the turntable in a straight line. However, if the turntable is moving, the marble curves to the right. As the heated air from the equator rises high into the atmosphere, it moves toward the poles. As this air moves away from the equator, it cools and sinks. When it reaches the surface again, some of it moves back toward the equator, and some continues to move toward the poles. As a result of this air movement, a series of prevailing winds are formed. As you can see, the continental United States is affected by the prevailing westerlies. Weather moves generally from the west to the east in the United States. Local weather is brought into an area by the prevailing winds. The weather conditions depend on the characteristics of the air mass that is moved by the prevailing winds. When air masses meet, a boundary forms between the air masses. The masses don't mix, but instead one mass pushes the other along. This boundary is called a front. A cold front forms when a cold air mass pushes a warm air mass. Because the cold air is denser than the warm air is pushed up quickly. As the warm air rises quickly, the moisture in the warm air cools and condenses. The water vapor changes to tiny drops of liquid water. Clouds form as a result of this cooling. The clouds that form are usually cumulus clouds. The size of the clouds depend on the amount of moisture present in the warm air mass. Precipitation is often heavy along a cold front. It may not last long, but it is generally a heavy rain with increased wind speed. Thunderstorms are common along cold fronts. During the winter, snowstorms and blizzards may occur along a cold front, depending on temperature differential and the amount of available moisture. A warm front occurs when a warm air mass pushes a cold air mass. The warm air moves up and over the cold front. Notice the movement of the warm air over the cold is at a much more gradual slope than at a cold front. The warm air does not rise as fast as it does in a cold front, so the clouds that form are different. They are thinner and spread out over a greater area. These clouds are called stratus. These high clouds are a sign that a warm front is approaching. A warm front moves through an area much slower than a cold front. The clouds associated with warm fronts are thick, low clouds that produce a steady, light rain. This may last for a day or more. Sometimes the boundary between a cold and warm air mass doesn't move. In that case, it is referred to as a stationary front. Sometimes when a cold front is overtaking a warm front, the warm front is actually lifted above the ground. This may create drastic temperature changes and violent weather. This type of rare front is called an occluded front. So, air masses moving from areas of high pressure to areas of low pressure bring weather from one location to another. Air masses take on the characteristics of the areas over which they form. As air masses make contact with each other, warm and cold fronts are formed. Clouds and precipitation may result.